Hello everyone, this is Android Lecture 2. We're going to go through Android's UI and resources and everything you need to do to build proper full-scale UI for Android. That includes lists, different kinds of layouts, background colors, being able to draw things on the screen, all of that. So the first thing we're going to start with is a little bit of an overview over context. We've done this a little bit before, but this is a bit more in depth. So it's an interface to global information about application environment. It allows access to application-specific resources and classes such as app calls, application level operations and launching activities, broadcasting, receiving intents, all of that kind of stuff. The basic idea is it provides the Android context to the code. Java itself doesn't know about Android stuff, so if you want to start a new activity, you need to communicate with the Android operating system. You need to use application level stuff, not just Java code. That's where you would use an Android context object. Activities are the most common type of context, and that's the one you use. Your actual application is also a context. They have different powers, and we can go over that later on. But activities are the most common kinds of context, and those are the most being used to instantiate views, to create other activities, all of that kind of stuff. Now, resources. We've also used this a little bit when we were doing XML layouts. So when we created our main class for Hello World, and then created a view in XML and specified that you're using the r.layout.activity_main in set content view on create in our main activity, we were using Android resources. So resources include things like images and strings. There's also values, dimensions. There's lots of resources that can be defined, and the beauty of it is it allows them to work to be maintained independently. So by externalizing your resources, it allows you to provide alternate resources that support specific device configurations such as different languages and screen sizes. You can, if you externalize all your strings into a strings file, then what happens is you can create multiple string files that have that support different languages, and all you do in your code is you refer to the string name, and it'll fetch it appropriately from the appropriate language. So if the phone's settings say it's in French, it'll fetch them from the French strings file as opposed to the English one. There will always be a default, so if it couldn't find a certain string in French, it'll go fetch it in the default, which is usually English. All of your resources go in the res directory, which is short for resources. There's lots of subdirectories inside that include different densities, so a drawable XTP, XHDPI, HDPI, MDPI, LDPI, and so on, so forth is TVDPI as well. There's also values V14, values V11, those depend by API level, so if you want to change your resources values based on API level. There's also styles in there, there's lots of resources in there. If you create a default Android project, you can look through and see many of them. So you define your resources in XML or just by throwing an image or something like that in your resources folder, and Android's compilation tools will create an R class for you, and all of your resources will have IDs associated defined in there. There's a special kind of resource called a drawable resource. This is what you generally see that isn't text. So when you're looking at an image, when you're looking at a background that's a certain color, or a gradient, or a rectangle that's being drawn on screen, or for example, if you're looking at when you're typing something into the search bar, that blue underline you see that scales with the text, that grows bigger and smaller, all of those are defined as drawable resources. There's many different kinds. Bitmap, as you may imagine, is actually just a bitmap. A 9-patch is a bitmap that can be scaled. So for example, as I said, that underline in an edit text or a search bar, the way it scales is defined in a 9-patch. A layer list has many different layers. If you've worked with the web, you can see that a lot. A state list is usually used for things like a button, where there will be different states for a button, whether it's being selected or pressed or focused or disabled. Disabled usually makes it gray, selected usually has a border around it, those kinds of state lists. A state list usually defines the states, and each state is associated with some other drawable, such as a color or maybe a stroke, a color all around. There's also level lists, transition drawables. You can read about these online. These are the ones that have supported so far. There's also animation drawables. I haven't mentioned them here. So the first type of layout that I'm going to go in depth in is the frame layout. It's designed to block out an area on the screen to display a single item. Frame layouts should be used to hold a single child view because it can be difficult to organize child views in a way that's scalable to different sizes without the children overlapping each other. I did mention this in the last lecture. When we created Hello World and created 4 views and put them in each corner, I mentioned that if your text was bigger than Hello World and you had a small screen size, the views would overlap. There is no kind of collision detection. The child views are drawn in a stack with the most recently added child on top. So if you have many items in your XML, the first one is the first one it draws, and then all the ones under it are drawn in that order. So the last one will be the one on the top. The next is linear layout. We've also gone through this one. It's a view group that aligns all children in a single direction, vertically or horizontally. You can specify the layout direction with an XML attribute or using the provided method. This is where you lay things out right beside each other. Now keep in mind that the size of the linear layout will be the size of all of them combined, not in an addition sense, but the maximum. So if it's a vertical linear layout, it'll be the height of all of them added together and the width of the largest one. And the opposite happens for horizontal linear layouts. So keep one thing in mind, that you can, even though you can change the default gravity for a linear layout, sometimes it doesn't work for all cases. If you have a vertical linear layout, you can center items horizontally. You can make them align right, you can make them align left, because it's placing things vertically. You can also specify the gravity to be down, so if you want them to stack from down up as opposed to up down. However, you cannot center them vertically if it's a vertical linear layout. You cannot center them horizontally if it's a horizontal linear layout. A relative layout, a view group that displays a child's views relative to positions. So here's where you can place items relative to each other or relative to the container. You can say this view goes at the top right of this parent, this other view goes at the bottom left of the parent, and this view goes to the right of that one and it's below that one. It's also aligned to the right of this one. So you don't have to always put things to the right or to the left or something. You can align the rights and lefts and go like the left of this view is aligned with the left of that view and the right of this view is aligned with the left of right of this view, and so on and so forth. Now, to be able to refer to different views within a relative layout and say it's to the right of this or to the left of this, you need to use resource IDs. We will get into these a little bit more later on, but you can give IDs to views to be able to refer to them later in code or in XML. Now, one thing I should mention here is relative layouts should not be nested, well, with other relative layouts. Because of technical reasons, measuring and laying out happens twice for every relative layout, and so if you have a relative layout within a relative layout within a relative layout, that innermost relative layout will be measured and laid out 8 times, and if you have another level, it'll be 16. It's very expensive and it could slow down your UI. Usually just do it by trial and error, try things out, use the view hierarchy view where there's a tool in Android that helps you do that, and make sure that things are not taking too long to render. So there's many other kinds of layouts. The ones I showed you right now are the most common. However, there are other kinds. There's grid layout, table layout, I think there's a sliding drawer layout, and so on and so forth. Most of these layouts are mostly the ones I covered already are the ones you're going to be using. However, every now and then you would end up using a grid layout or table layout. Now, one thing to keep in mind with all layouts is, well, most of layouts, is that they don't handle touch events. So they don't allow you to scroll. They don't do any interactive features. They just put things beside each other. To be able to scroll and do things like that, we need to use ListViews, ScrollViews, grid views, that kind of stuff, which are very interactive and handle data appropriately and allow you to scroll. We'll go over those in a second. Layout underscore something. So you'll see a lot of times you'll specify layout underscore width, layout underscore height, layout underscore gravity, layout underscore to right of, layout underscore center and parent. Whenever you specify layout underscore something on a view, it's basically relative to its parent. It's telling them, so layout parameters for the view that are appropriate for the view group in which it resides. So if I have a text view, I want to put it to the right of some other text view, I need to make sure that the parent is a relative layout. And then, if my parent is a relative layout, I have the option of specifying layout underscore to right of. So it depends on the parent. What layout underscore parameters you have depend on the parent of that view. So list view. So how do lists work? So let's say you're looking at 10,000 contacts in an Android app. Imagine if the system would actually read through all of those and create views for them and display them all in a linear layout in a scroll view so that it can scroll. It would take a lot of time, and chances are it would be useless computation because chances are the user is not going to look through all 10,000 of them. He's going to look through a few. So it's much better to have something dynamic that will show views as you look at them and also remove them when you're no longer looking at them. So it'll only compute things that are necessary and only do them on the spot. So that's what a list view does. But the problem with that is the amount that you're going to see is going to be highly dependent on the user's interaction. You can't know it previously. You need something dynamic, which means when you're doing your view in the XML, you can't predefine what views will be associated with it.
Oh yeah, you have a point.
So you can't do it in sorry about that. So you can't do it in XML. You have to do it in code. And the way that works is every list view or adapter view in general is associated with an adapter. So a list view is a view group that displays a list of scrollable items. The list is automatically inserted to the list using an adapter that pulls content from a source such as an array or a database and converts each item result into a view that's based on the list. So the list view keeps track of what's happening on screen. And when it detects that a new item should come in or an item should go off, it communicates with an adapter. And the adapter will fetch the data and views appropriately as needed. So when you create a list view in XML, you don't specify its children, you don't specify the data that comes in with it. In code, you take your list view, then you add to it an adapter, you set an adapter on it, and you define the functionality of the adapter, how it communicates with your database, how it creates views and all of that sort of stuff. So there's many kinds of adapters. An adapter is an object that acts as a bridge between an adapter view and the underlying data for the view. Adapter views are views that use adapters, so grid view, list view, things that require data to come in and out dynamically. So the most common type of adapter most common types are BaseAdapter and simple cursor adapter. A BaseAdapter is your regular adapter that just has the basic methods that allow you to specify a count, define the item that's being used, and create a view. A simple cursor adapter provides a little extra functionality to work with a database cursor. So if you're using database access, you don't want to have to write all of the cursor manipulation and database manipulation on your own. A simple cursor adapter does a lot of that for you. Now, let's say you don't have items that are going to be added and removed, so you just have one big text article. So there you don't want to really use a list view because it's only a couple of static content that you do want to be able to add in XML or just statically and keep them there, but you want it to be able to scroll. If you put in a linear layout, it won't actually move up and down. It'll just stay frozen. That's what a scroll view is for. It's a container. It's basically similar to a frame layout, which means you can't put multiple inside unless you want them to, as I said, go on top of each other, have transparencies and stuff. But usually what happens is you have a scroll view, and within it is a linear layout that's vertical, and then within your linear layout you have a lot of items, and the scroll view will allow you to scroll up and down and view all of those items. We will do a demo of this in the lecture, in class, sorry. So a scroll view is a container similar to a frame layout. The only extra is it actually provides scrolling content, and the content inside can be much larger than the actual view. Even though the scroll view will only be as big as the content, as you scroll, the content inside can be huge. It's the same thing on a website. The website can't fit on your screen in one point, but that's all you can see, so that's how big that view is. However, the content inside is really big and you can scroll it up and down. Now keep in mind, the scroll view only scrolls vertically. To use horizontal scrolling, you have to use a horizontal scroll view, which is very similar but has a little different functionality to be able to lay items out horizontally as opposed to vertically. You should never ever use a scroll view with a list view because a list view takes care of its own vertical scrolling, and a scroll view will also try to scroll. So when there's two different views conflicting with each other in terms of who's supposed to scroll and who isn't, things will act weird. Actually, this applies in general to any view that can handle touch events and be interactive with touches. You don't want to put some other view within it that will interact with touches in the same direction because they will conflict with each other. Now buttons. This is almost, we're near the end now. So buttons. there's two parts to buttons. One is how you define them and how you get them to just show up and look good and that kind of stuff. And then there's actually handling the click events. I'll go through the UI first. So a button consists of text and an icon, or sometimes it's both, that communicates what action occurs when the user touches it. Three basic formats. There's the text, just a button such as submit, cancel, OK. There's image buttons, those things you can see usually at the top, refresh, share, the Facebook icon, that kind of stuff. And an image plus text. Now what differentiates this from a regular text view, because text view can also just be text, or an image you can have an image and then an image and text can be placed in the text view. What differentiates it is being able to be pressed. It can be pressed, it has provided functionality for on clicks, it also has states when it's pressed, selected, disabled, highlighted, focused, all of that kind of stuff. So you can use these to create your buttons and include in the layout. It works like a regular view. You specify a width and a height and you can put a background. Usually the background needs to be a state list so that you can handle all pressed states, or else it will be a static image and then when the user presses it you won't get feedback. Now responding to click events. A button has an on-click that you can define in XML. In XML, if you define your on-click to say, for example, you write in a string, you write in the method's name, you say on submit clicked, then what will happen is the activity associated with that click needs to have a method that will work with that on-click. In your activity, you need to define a public void method that takes in a view that has that name, and then you will just receive the on-click event there. We'll go through this in depth. Now, if you don't want to specify it in XML and you want it to be a little more dynamic and you want to do it in code, you can do that in code as well. You can get the button using its resource ID. You define a resource ID for that button, you fetch the button. Once you have that object in code, you can set an on-click listener on it, which receives click events. We will go through this again, there will be more demos on it later on. Adapter views usually have an on-item click listener, because then you have a list of many items. You don't have to define one, but you might, in many cases you do want to. So if you have a list of many items and you click on one, you need to be able to detect which one got clicked and how to handle it. You usually set an on-item click listener in code, and then you say if it's position blah, you handle this, if it's position blah, you handle this, and so on and so forth. This usually works very closely with the adapter. I will have similar on long click functionality, so when you long click you can also handle that as well. You don't have to define it, but you have the option. There are other states such as pressed, selected, focused, disabled, that kind of stuff, and they do have listeners, but they're not very often used. You can look them up when you need them. So in conclusion, I threw a lot of information at you guys in this lecture as well, but unfortunately all of it is important. So everything we learned about UI, you will probably end up using at some point. It will be difficult to learn all of UI's workings, especially since I missed a lot. There's still quite a bit more to Android's UI, but this is the basics to just get you going. But if you remember to check the documentation, if you have a problem with UI, I would recommend you go to Android developers' website and read there before you go on Stack Overflow and read there. Because chances are, Android's always updating, and a lot of the questions on Stack Overflow are now outdated. They're from 2008, 9, 10, 11. And now Android has been upgraded a lot since then. So go read the documentation, understand what's happening and why you're having that issue, and if you don't find anything there, look on Stack Overflow or ask the question yourself. Eventually you'll learn everything that I mentioned in here, and probably a lot more. But this is the basic idea of how you deal with UI. One other thing we will be I will do in the demo is show you how to actually work with on-click events and make them more function. Do things in on-click events. So start another activity, for example, and that kind of stuff. That uses context and intent. And I guess that's it. See you guys in class, and we'll build some awesome UI.